So in this part of the lesson, we're going to go ahead and look at right triangle trig just a little bit more. It wants us to evaluate the 6 trig functions of the angle theta. And there is a little acronym you can use. I'm not going to go through the story at this time. Some of you heard the story last year. SOHCAHTOA. And then if you think he has a girlfriend and his girlfriend is CHO, SHA, cow. And basically this means sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And then the cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, cosecant is adjacent over opposite. So we basically need to figure out which ratio we have and figure out the rest of them. So right now, I've got this theta, meaning this is the opposite and this is the hypotenuse. So we know that opposite and hypotenuse is sine. So I know that the sine of theta is 15 over 17, which means that we get the cosecant kind of for free because I can flip that. Unfortunately, I need the adjacent leg to figure out anything else. So I'm going to use the Pythagorean theorem. And remember, the Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. So my leg is 15. I don't know this, so I'm just going to call it x for now. And my hypotenuse is 17. So 15 squared is 225. 17 squared is 289. Let's see if I have this one. I don't think I do. No. I'm going to subtract that. So I get 64, and then the square root of that, and remember we don't do negative square roots when we're doing geometry-like things, is 8. So I know that this side here is 8. So now I can get my cosine would be my adjacent 8 over my hypotenuse 17, which means I get my secant by doing the reciprocal of 17 over 8. My tangent of theta would be the opposite 15 over the adjacent 8, and my cotangent would just be the reciprocal 8 over 15. All right, let's look at this other triangle. So it looks like I have the adjacent leg and the hypotenuse this time because I'm next to the theta and I'm across from the right angle. I'm missing the opposite leg. But I know for sure that gives me the cosine of theta equals 5 over 5 square root of 2. Now, I'm not sure what WebAssign is going to do to you, how much they're going to have you reducing, okay? You might have to reduce this, but for calculus, you don't need to reduce anything and you don't need to rationalize. However, probably WebAssign is going to do that to you, so I'm going to kind of keep going here. So this would reduce to 1 over square root of 2, which for our secant purposes is square root of 2 over 1, or just square root of 2. But I would probably need to rationalize this to get the answer in WebAssign. So square root of 2 over 2. Remember, radical times itself is just the number underneath because it would be square root of 4. The square root of 4 is 2. All right, the opposite, I need to figure that out. I'm going to use the Pythagorean theorem over here. So I'm going to go my leg squared 5 plus my other leg I don't know equals 5 square root of 2 squared. So 5 squared is 25. 5 squared again is 25, and the square root of 2 squared is just 2. So I'd get 50. And I subtract the 25, I get 25. And then take the square root, and I get 5. So this is actually a special right triangle, which we're going to see a little bit later in the lesson. So my sine is going to be 5 over 5 square root of 2, which you know is exactly the same as this, so it's going to end up being that same answer, square root of 2 over 2. And then the cosecant, which is the reciprocal, is going to be the same reciprocal as this one here, so it's just going to be square root of 2. And then the tangent, again, is the opposite over the adjacent, which is 5 over 5, or just 1, and the cotangent, of course, the reciprocal of 1 is 1. So in this next two examples, they just didn't give us the triangles, so we have to draw our own triangles. That's the way I would think about it. So I'm going to label a theta, not to scale, okay? I know theta is opposite over hypotenuse, so my opposite, sometimes I still label in here. My opposite is 4, my hypotenuse is 7. I know I'm going to need to find that angle right there, or that side right there, so I'm just going to go ahead and put it into the Pythagorean theorem. It's not going to be pretty. So 4x squared plus x squared equals 7 squared. So 16 plus x squared equals 49. So x squared equals 33. And then we're going to have x equals the square root of 33. So this is the square root of 33 there. Now, it shouldn't be very hard to find the other values. Actually, what I should have done right away was I know that I get for free the cosecant. I should have listed that one right away, is 7 over 4. So now I need the cosine, the secant, the tangent, and the cotangent. And as you're doing notes, be careful not, if you're using the note page, don't mark in those, because remember, that's any mark in there sends that to your Google Drive or wherever you have it. So only mark in there the one you need, okay? All right. So the cosine is the adjacent, the square root of 33 over the hypotenuse, which is 7. And then I'm going to flip this, which means that I am going to have to rationalize it to get the right answer in WebAssign. So 7 square root of 33 over square root of 33 times square root of 33 is 33. Okay. The tangent would be the opposite 4 over the square root of 33. So now I'm not going to rationalize that yet. I'm going to flip it first for my reciprocal, and then I'm going to rationalize. That way I don't get the wrong reciprocal answer or have to rationalize again. So 4 square root of 33 over 33. All right, let's try one more. So I've got another triangle. Doesn't matter which order I draw it in. I happen to draw it slightly differently. This would be my opposite, my adjacent, and my hypotenuse. So sine, again, I hope I managed to get sine in there twice. It's opposite over hypotenuse. It could be any of the 6 to start with. So opposite is 3, hypotenuse is 8. I need to find the adjacent leg. So I'm going to do my Pythagorean theorem. So 3 squared plus the other leg squared equals 8 squared. 3 squared is 9. 8 squared is 64. I'm going to have to get my calculator out because I don't want to mess it up for you guys. So we have x squared equals 55. So I'm going to take the square root of 55. So it's just the square root of 55. I don't believe that breaks down in any way. All right, so for free, again, I should have gotten the cosecant for free, which would have been 8 over 3. The cosine is the adjacent square root of 55 over 8, the hypotenuse. Secant, I'm going to flip the reciprocal of cosine. So 8 over square root of 55. I'm going to rationalize that. So I get 8 square root of 55, and then square root of 55 times square root of 55 is just 55. And then the tangent of theta would be my opposite 3 over my adjacent square root of 55. I'm going to flip my reciprocal first, and then I'm going to go back and rationalize. So I'm rationalizing by multiplying the top and bottom by that radical. So get 3 square root of 55 over 55.